Hello guys, in today's video we are going to learn about a greedy algorithm that comes to offer optimal decoding discovered by David Huffman in his studies at MIT in 1951. But before getting into the action, let's match our expectations. I'm studying this topic by myself and my videos depend on the wisdom of the crowd, a topic that really fascinates me. Therefore, if you find any mistake in what I say, please let me know in the comment section below. I promise to read all comments and re-upload if necessary. Also, please subscribe to my channel. I tend to upload many videos on this topic. Alrighty. Huffman code is an optimal prefix code that receives the frequency of each letter in the alphabet of the document. The goal of the algorithm is to code the least frequent letters of the alphabet with longer code and the common letters with shorter code. So the eventual way the document be decoded be as efficient as possible. An essential aspect of this method is to ensure that every letter coded uniquely, and there is no way to interpret the code differently than the way intended. Let's see an example. Alrighty, Huffman code. A prefix code is a type of code system which requires that there is no whole code word in the system that is a prefix of any other code word in the system. For fixed length code, this can be enforced easily. You simply code every letter of the alphabet with a different fixed size code. A good example to such a coding system is the ASCII system. That system codes every letter with exactly 8 bits. Hence, you can code up to 2 to the power of 8 different characters. And indeed, the ASCII system coded all the English alphabet, capital and lowercase, 52 characters in total, digits and basic signs. Here is an example to a non-prefix code. Its code is 1, B, its code is 0, and C, its code is 10. Notice that, given the code 10, we have no way to determine if we should decode the code as AB or just a C. An Huffman code builds a full binary tree. Every non-leaf vertex has 2 children vertex for the alphabet of the document. It positions the letters only on the leaves. The more deep the leaf is, the less it's frequent. The algorithm of the Huffman code picks on each iteration the least 2 frequent characters and places them as children of a vertex which does not represent any letter of the alphabet. That vertex gets a frequency which equals to the sum of frequencies of its children vertices. A left son gets the bit 0 and right son gets the bit 1. Let's see an example. The letter A, its frequency is 6. The letter B, its frequency is 5. The letter C, its frequency is 4. The letter D, its frequency is 3. The letter E, its frequency is 2. And the letter F, its frequency is 1. Alrighty, so as you can see, F and E are the least frequent letters. We would place them first. So we placed F as a left son of father 1 and E as right son of father 1. Father 1 is our new vertex, which of course does not represent any letter of the alphabet. And its frequency is 1 plus 2, which equals 3. Alrighty. Father 1 and D are the least next frequent letters. We would place them next. As you can see, the frequency of Father 1 is 3, and the frequency of the letter D is 3 as well. Therefore, the frequency of Father 2, the next vertex, which again does not represent any letter of the alphabet, is 6. Next. So the next 2 least frequent characters are C and B, which have the frequency of 4 and 5 respectively. Therefore, we're placing them under a new vertex, Father 3, which has the frequency 9, 4 plus 5. Next, A and Father 2 are the next least frequent letters. We would place them next, under Father 4, which its frequency is 6 plus 6 equals 12. Now, Father 3 and Father 4 are the next least frequent letters. We would place them next, under father 5. And therefore, the frequency of father 5 is 12 plus 9, 21. Father 5 has a frequency equals to the combined frequencies of all letters in our alphabet. 6 plus 5 plus 4 plus 3 plus 2 plus 1 equals 21. Done. And here is our Huffman code. Let's see it for the letter A, for example. So letter A is here. We're going to the right son of father 5 and then to the right son of father 4, and we're getting A, which means 1, 1. That's the code. And we are doing the same process for all other letters. Cost of code. You can calculate the cost of your code by multiplying the depth of each letter multiplied by its frequency. Afterwards, you add up all results. So A, its frequency is 6 and the code is 1, 1 and the depth is 2. B, its frequency is 5 and the depth is 2 as well. And C, the depth is 2 as well and the frequency is 4. And D, its frequency is 3 and the depth is 3. E, its frequency is 2 and its depth is 4. F, its frequency is 1 and its depth is 4 as well. So we're combining all results and getting 12 plus 10 plus 8 plus 9 plus 8 plus 4, which equals 51. Well, that's the story. I hope you learned something new from this video, and please comment below with your thoughts. First degree studies in university are all about social studies, and this project comes to encourage that, even through complicated situations most of us are going through right now. Please subscribe to my channel and comment with your thoughts. I hope to see you soon. Good luck.